Hello. Um, well, there's someone actually there. How interesting. Hello, Megan.
Hi.
Um, okay. Now, what I'm going to do, I'm not going to share the screen so you can see the goriness, but I am going to start a PowerPoint. Uh, a new PowerPoint. Now, we're going to talk about people. The
Well,
Hey,
wow, the volume is pretty low.
well, you're not very loud. Am I loud? I'm getting green dots. Okay, what I want to do is share my screen. Actually, I should probably start a chat bar somewhere. Um, there it is. And share my screen. And so I'm going to start that. Okay. Now, what I want to talk about here is um, somewhere we have a blank. All right. Now, the nice thing about PowerPoint is it actually is set up to, it has virtually all of the flowchart shapes defined for you. Uh, so you can um, easily do flowcharts in PowerPoint. Um, Now, in fact, almost all of the ones you need are here in the same flowchart. So um, the I found a good flowchart reference guide on smartdraw.com, and you can get a free download of what the flowchart symbols mean. But honestly, what the symbols mean isn't that important, except for one, and that one is the decision symbol. All the others, you can use rectangles. The the, the specifics really don't matter all that much. Now, the funny part is that some of the symbols that you would have in a flowchart are so ubiquitous as shapes that they're up here. Um, the start-end ovals would be here. So you can put an oval, and that would be a good start point. Now, if you want, you can then put text in. But what is it we really want to do? In this. I'm not actually going to write the code, but you have a starting place. And so what you're doing when you write a flow chart is you're writing down symbolically everything you need to do. And one of the nice things about PowerPoint here is that you can then go in and put text on top of these, and you can and arrows that connect them, and it gives you some logical sense of what it is you're doing. So as you think about what it is you want to do, now the hexagon is a symbol for preparation. And in Arduino code, you basically have two defined subroutines, and I think that's all you get. The startup and the loop. Now let's see if we can't define the loop that we want to have. So I've put my arrow there. Now, let's see if I, oh good. Start. Now, what we put in the preparation box will depend on what's needed. So one of the things I know we're going to need is define variables and so the main loop, what are we going to do in the main loop? the thinking comes in. This is the important part. Before you actually to the flowchart part, you have to really decide in some rather specific but nonetheless global sense what the program you're writing is going to do. Now, most of the programs we're going to write until we start to get to the data analysis phase are Arduino programs that collect, transmit, or store data. So the there's actually a symbol in the symbol um, what we may want to do here in the loop. The first thing you want to do let's assume that we're going to write memory in a single data stream that's the same as the data stream we're sending to the telemetry. We're just writing it faster. Now, what I don't know, and what somebody's going to have to look up, is how much buffering the RS-232 sequence has, because otherwise this is going to be a challenge. Suppose we can start with a yeah. Now, I'm not sure quite what I need to do here, but we can put in a little text. Okay, so now what happens if it is the start? Well, we have actions we'll want to do. We'll write the sync word over here. You'll want to go and get data ADC. What we're doing as we do this is we're thinking up everything that we need to do to produce a data frame. Now, that doesn't work. I'm trying to do I guess I have to do this the hard way. I'm not. Yeah. Did somebody just chat or something? No. What I'm trying to do is to draw an arrow that goes this way. So I should just come in from the side. No? I'll go and come in from the side on the next box. That may be what I'll do. Up here we want to set word count. Probably you'll be saying the word 4 or set byte count. Okay. Is that what I wanted to do? No. We'll fix that. What we want to do now, introduce a process here. This would be output. We always output to storage. Okay, now, I'm going to want to continue on the next line. So we'll continue, and we'll get a new page. And we'll start right away with a decision. I wanted to move it. I did want to move it, actually, yes. Also make it bigger. So at this point, what's a question we have to answer? Presumably, we're going to write to storage much higher data rate than we write to the RS-232. Now, I'm hoping that there is a buffer in the RS-232 that we can write 10 words real fast, or 16 words real fast, the stream, and it will store them and put them out. And something that you all need to look up, I'm going to go over to the actual Hangout. Okay, I'm now looking at you guys, not looking at my screen. What you're going to have to figure out is how do we I guess the question really is, how do we interleave storage to high-speed onboard SD card, which can be written to a much higher rate than the RS-232 card. And the question really is, how do you do that?
So that's going to be different baud rates, right?
You'll have to turn up your volume. I can't hear you.
Oh, I mean, so they're going to have different baud rates. Is that right?
Absolutely. And the way what you want to do is take, say, every 10th word, 16th word, in each quantity and write that to the RS-232, and then that would be say 100 baud, and write the others, all of them, to the SD card. Now, the question is, from a logical standpoint, there's an easy way to do this, which is to every 16th time through the loop, write to both. This presupposes that there's a hardware buffer in the R32 or USB port shield that will let you spit 16 words at it real fast, and it will store them up and send them out slowly. Now that's a what does the manual tell us question that you guys have to look up in order to get this programming written. Because I don't know the answer to that. Is there how big a FIFO buffer is there on the UART chip or in front of the UART chip? That's a hardware question that if there's no hardware buffer, that makes this flowchart much harder, because what you have to do is build the timing of when you write to the RS-232 port into the loop that is to the SD card, such that what I'm about to do here on my on this flowchart, what I'm about to do is to ask, is this the 16th time, or is this our first time through? If so, write to the USB, write to the RS-232, and also write to the memory. Now, if there's no buffering in the RS-232, then what we're going to have to do is to figure out, suppose our ratio is 16:1. You're going to have to figure out how long one data acquisition loop takes through all 16 or however many words we're sending. And then let's suppose that we can write a whole frame of all the words to the SD card in between the time it takes to get just one word out, 2 bytes out the RS-232 link. Then what we would have to do is send the next line out. The decision here on this, at this point in the flowchart, gets a lot more complicated, because you have to keep track of both where you are in each frame and how many frames have gone by, so that you're doing the simultaneous multiple transmissions correctly.
Word and no other functions.
You know, you have to say it louder, whatever you. So whatever we need to do is a question that has to be answered by looking carefully at the RS-232 USB Shield manuals, because they will have the information you need.
On the Arduino website, they said it has a 64-byte buffer.
Wait, you'll have to say that much louder.
Oh, I'm sorry. So on the Arduino website, they say it does have 64 bytes of buffer, receive buffer.
Okay, so there's a 64-byte or 32-word buffer.
Yes.
So there's going to be some arithmetic here, because that buffer is for going to the RS-232 line.
There's 3 serial ports in Arduino Mega, so I'm guessing 364 buffers for each.
I'm not
I mean,
hearing you.
64 bytes. There's 3 serial ports for Arduino Mega, and I'm guessing 64 bytes for each.
Okay. The question is for me, and I'm just not hearing your words because you're not talking enough. You need to turn up your microphone. This is a settings on your computer, because I know you're talking loud. The microphone isn't set loud enough. But I really didn't hear most of that. But it depends on which output stream is being buffered. The buffer, you could separately buffer the output stream to the USB port or RS-232 port, and you could buffer the output stream to the SD card. And those statements really should be on the shields that we're using, not so much on the Mega. Now, the 64-byte buffer on the Mega is for what? That's a channel-dependent statement. What channel is being buffered? And you may have to answer me next Monday, but
I'm sorry, does it sound better now?
what?
Does it sound better now?
Not really. The I'm let me look at my settings, see if I have some speakers. Okay, my speakers are kind of quiet. Well, that didn't work. Okay, yeah, that's fairly loud. Okay, so the basic Abdul left. That is not helpful, because you're the one we need to be talking to. Basically, we need to know what the buffering is on each of the two output channels separately in order to really design this flowchart. But let's assume that there's enough buffer on the RS-232 to so let me go back to the chart, and we'll write time through. So we'll assume that there is enough Okay, so, and we're going to go over here and do no. This is no. Now, I'm not really writing the one that you're really going to use. I'm illustrating you're really supposed to be listening to how am I thinking about this? So I'm asking myself, okay, now here we have a process which is now n can either be 4, well, n will either be if we have just n is either the 4 bytes of the sync word or it's the 2 bytes of data word. So then we increment word counter. Over here, so we may need a more complicated interleave. The buffering isn't adequate. Now, we have another decision. And that decision is, are we at the end of the frame? Okay, so now, if in either case, what is going on? I has stopped responding. Why did it do that? Okay, so This would be no. Hello, someone there? And this would be yes. So we have a process increment frame counter. And actually this should be modulo. This is first time through modulo 16 question mark. Be modulo something. That has to be worked out. And so, and this up arrow will actually end up here. So you basically have this main loop that's very simple, but you have to sort of keep track of how many you've been through it and where you are through it. It's actually we're using the test questions to run 3 nested loops. The inner loop is simply go get a piece of data and write it, either to storage or to RS, and write it somewhere. That's the fastest, simplest loop. The second piece of the largest loop is every time there's a frame, you're which is some words, you're incrementing your frame counter, and once in a while, you're going to implement a how do we put this? The innermost loop is the words. The secondmost loop is the frame. And so you keep track of which frame that's in. And the outermost loop is that every n frames, where n is maybe 16 or whatever we define, you don't just write to storage, you write to RS-232. Now, the complexity is going to come. The only real complexity is if you have multiple data streams coming. If you have, for instance, and unfortunately we'll probably have this on the very first flight, if you have the TEC sending data and you have weather shield on the payload, what you're going to do, the weather shield will presume pressure, temperature, humidity, I don't know if there's anything else, but say there are 3 or 4 variables on the weather shield. Read those 3, And then you will turn around and read whatever the TEC's frame length is going to be. Basically a satellite number, a time, a satellite number, and 2 phases. So presumably that's 1, 2, 3, 4, 5, and if that's 11 bytes. That supposes we're going to do quite a bit of processing on the ground in terms of translating the time and satellite number into a look direction from fiducials. I guess you'd want to have time, satellite number, balloon position, and then all those phases. So you might have some significant number that you're getting in a burp from the TEC, and you're going to have a handshake over the 32 on that data, and then whenever that frame, and then ship that frame out on the RS-232 and the data storage, then turn around and get the weather shield stuff over again. And so you'd alternate weather shield, TEC, weather TEC. So that actually is somewhat more complicated. But the key is to think through what you need to do in an orderly way. And what my thinking this through did today is we realized that we have to understand the buffer structure on the where. Now, I have not given you a more general how do we write flowcharts lecture here. But the truth is that computers are really, really dumb. They do exactly what you tell and only what you tell them. So if they're doing weirdness, it's because you either told them something that didn't make much sense, or they didn't understand what you had to say. Now, honestly, the programming language, the syntax of writing down all this stuff is trivial. It's really not hard to learn programming syntax. It's the stuff about where the commas and the semicolons go, and whether or not you have to worry about if the letters are capitalized, and a few other really dumb things like that. But virtually every computer language I know of refers to the sign as either sign or, as sign, parenthesis, argument, unparenthesis. There's an awful lot of commonality between the computer languages. If you know one, you've learned them all. That's not quite true, but it's close. That's why computer science schools typically only teach programming in one language. The rest of them you're supposed to pick up. But the hard part is figuring out what it is you're going to do. Now, that isn't what I do. I wanted to go back to not sharing. Okay, so we seem to have lost Abdul. Well, okay. We're near the end of the time. So the hard part about designing the program for what we're going to do in August and what you're going to do next March is your flowchart. And the flowchart comes from your data allocation, frame design. So the first step is to figure out what the data rates are for each of your variables and to design what your data frame, meaning what the order of words and the repetition rate of the different words is going to be. Because sometimes you have a data frame in which you have what are called subframe structures. And you may have, the data frame may last a second, but there are subframe structures that happen every 16 milliseconds. I've had one like that. And so some words are sampled every millisecond, and so you have just a huge long column, whereas some are sampled, some ratios more slowly, and the result is a funky looking matrix of what's happening when in your data, in the data stream. And it's called a frame, and it can be it's best expressed as a matrix with the understanding that each byte is transmitted serial left to right, top to bottom, as if you were reading it. And the use of a matrix allows you to keep the subframe structure organized in your head. That's why I asked all of you some time ago to identify the variables you were transmitting and to assign a data rate to each one. And there's going to be some tugging and hauling and adjusting because it has to come out to be less than 1200 baud. For the live transmissions, it can be much higher for the storage. But you have to know what you're going to do. Once you know what you're going to do, then actually, so that's the place you start in all this programming software stuff. And I have had questions from some of you like, well, which do I do first? Read from the weather shield or read from the GPS shield? And the answer is, I couldn't begin to tell you because I don't know what your data frame looks like. And until I know what your data frame looks like, you can't. Once you know what your data frame looks like, the data frame more or less dictates what the flowchart is like. And that question gets answered in the course of writing the flowchart. Once you have a good flowchart, actually making the flowchart into code is very simple and can be done more or less by cutting and pasting from a lot of go-bys that you have that come with the Arduino. The hard part is writing your data frame. So, and the reason why it's proving challenging is that you don't yet have a set of 10 specifically defined, this payload has these experiments payloads. So the flowchart of your understanding is, number one, define a set of payloads. That means you need mass estimates. Number two, and you need to understand the science well enough to know which experiments go together. Number two, you need to define, now Rachel's done a start on that, but all of you need to contribute. Number two, for each of the payloads, you write down a data frame. And the data frame is either simply a row of variables. If you're going to sample them all at the same frequency, and they're all going to be 16-bit words, then that pretty much tells you what your data frame looks like, because you divide. If you have, remember, 1200 is bytes, means bytes per second. So you, you may not need 1200 baud. That's a lot of data. If you're really thinking about making a measurement every second, remember that's 600 words, two byte words every second. So that's 600 measurements. And most of our, if we use the naked Arduino, we have 6 variables. So that means they're measuring, in fact, measuring 100 times a second, your 6 variables. It's, for Rachel's experiment or Chris's, sure, that makes some degree of sense. For most of the rest of you, what? So you got to figure out what you want. 1200 baud is a hell of a lot of data for a lot of these experiments. I mean, the temperature just doesn't change that fast. Okay, that is the end of my hour of questions. The one thing left was, huh?
Oh, I'm just saying no questions.
Oh, okay. The one thing we learned today, and I hadn't thought about it, is we need to understand the available buffering, because that will strongly define the structure of your flowchart for each of these experiments. Because the RS-232 is going to go slower, a lot slower than the on-board. On the other hand, for virtually all these experiments, there's like no reason to go much faster. The only experiment that has to go faster than the telemetry, the only experiments that will go faster than the telemetry allows are the particles and, well, let me correct myself. The particles, the star tracker, the spectrum, and Rachel's experiment all potentially could have television level data streams. You know, hundreds of, I mean, Rachel's experiment generate a data stream of 100 kilobaud if we let it. That's a big data stream. The particle detector, the spectroscopy, and the star tracker, even more. They'd be television level. But everything else, we may not have to fight this buffer problem. We may just want to produce 1200 baud going both directions which makes the flowchart a hell of a lot simpler. Because I can't conceive of why you would want to record the temperature or the pressure or even the position more faster than a total data of 1200 baud. I'm willing to be educated. Educate the faculty is the purpose of this project. Okay. Well, I have an appointment very shortly with my driveway contractor, so I think I will call it a day. You can all join me. 1, 2, 3. It's a day. And we'll kill the broadcast.